Welcome. In the next few minutes, we are going to completely change the way you find answers in your logs. We're going to go from the chaos of digging through endless files to the pure clarity of a single dashboard. This is your hands-on guide to Grafana Loki. So let's kick things off with a scene that's probably all too familiar. An alert fires. Your phone buzzes. Prometheus is great. It tells you exactly what broke. The CPU is redlining. Error rates are through the roof. But that's just the symptom, right? The real question, the million-dollar question is why? Well, stick around because you're about to see how Loki answers that question instantly. For most of us, finding that why kicks off what I call the hunt. You're SSHing into 10 different servers, you're running these crazy, complex grep commands, trying to stitch together a story from all these scattered log files. It's a total mess. Now, what if you could go from that alert to the answer in one place? That's the whole promise of Loki. One dashboard, one query language, and all the context you need right at your fingertips. So here's our game plan. We'll start with why logging is such a headache in the first place. Then we'll dive into Loki's clever architecture, its query language, and how to actually get your logs in and visualize them. And we'll wrap it all up with some must-know best practices. Let's do this. Okay, first things first, let's really dig into the pain points we're trying to fix here. I mean, why is dealing with logs from all our different services just so hard?
I bet this slide hits home for a lot of you. You felt this pain. It isn't just the manual work, it's the mental overhead of trying to match up timestamps and decode 10 different log formats, all while your system is basically on fire. And the big traditional solutions, man, they're often way too complicated and way too expensive.
And that brings us to a really fundamental difference in approach. You've got systems like the Elk stack, which basically index the entire content of every single log line. It's super powerful for sure, but it is also incredibly expensive. We're talking huge storage and memory costs. Loki's approach, it's way, way smarter. It only indexes a tiny bit of metadata. We call them labels. The actual log data gets compressed and tucked away in cheap object storage. We're talking like 10 to 100 times cheaper. And this right here, this quote just nails it. It's the core idea. If you already get how Prometheus uses labels, things like job, instance, namespace, then you're honestly already halfway to understanding Loki. It just takes that same powerful, efficient idea and applies it to logs. That's the magic. All right, so how does this all come together into a system that's both simple and can scale like crazy? Well, the secret is in the architecture. So it all starts with Promtail. That's the little agent that grabs your logs and slaps some labels on them. It sends them off to the distributor, which is kind of like a traffic cop, making sure logs go to the right place. That place is an ingester, which bundles logs up into compressed chunks. Then, when you run a query, the Querier is smart enough to grab recent stuff from the ingesters and older logs from long-term storage. This whole separation of reading and writing is what lets you scale each part independently. So where does everything actually live? Well, the log content itself, those compressed chunks, they go into cheap object storage, like S3. But the indexed, which just has those small, efficient labels, is stored somewhere else entirely. And that separation, that's the secret sauce. You get super cheap storage for the bulk of your data and a tiny, lightning-fast index for your searches. It's really the best of both worlds. Okay, now for the really fun part. We've got our logs in Loki. How do we actually find anything? Let's get our hands dirty with LogQL, Loki's awesome query language. Every LogQL query basically has two parts. First up, you've got the log stream selector, the part in the curly braces. This is where you use your labels to instantly narrow down the millions of log lines to just the ones you care about. It's super, super fast because it only touches the index. Then you can optionally add a log pipeline to filter or parse the actual content of those logs. Now check out these operators. The top four, those work on your labels in the stream selector. They're your first line of defense, your fastest possible filter. The bottom two are line filters. Think of them like a distributed grep that runs across the log content after you've already picked out your streams. Understanding that difference is absolutely key to writing fast query. But this is where Loki just completely blows my mind. If you have structured logs, you can use a parser like JSON to pull out fields on the fly and then filter on them. And check this out, this is the really wild part. You can run metric queries, just like you would in Prometheus, directly on your log data. It totally blurs the line between logs and metrics in this incredibly powerful way. Of course, none of this works unless we get the logs into Loki with the right labels. And that is the job of our lightweight little friend, Promtail. Now, if you've ever used Prometheus, Promtail's configuration is going to look super familiar. It's just a simple YAML file. You tell it where your Loki server is, and then you set up these scrape configs. In this example, we're just telling it to watch all the log files in /varlog and attach a simple label to them. It's really that easy to get started. For more advanced stuff, Promtail has this awesome processing pipeline. It can automatically find all your Kubernetes pods and grab labels right from their metadata. And then you can add more stages to, say, parse the log lines with a regex, pull out a severity level, and turn that into a label before the log even leaves the machine. It's so powerful. Okay, let's put it all together inside Grafana. This is where the magic really happens, and you see how all these pieces create something amazing. This right here, this is the killer feature. Once you've added Loki as a data source in Grafana, you can do this. You see a spike in errors on the Prometheus graph, you click it, and boom. Grafana instantly pulls up the exact log lines from that exact moment in time with the exact same labels. It is an absolute game changer for debugging. And here's what that looks like. You've got your Prometheus metrics right up top, and right below it, the Loki logs that correspond to that data, filtered automatically for you. This is the aha moment. This is what transforms your workflow. You go from what broke to why did it break in seconds. You never even have to leave your dashboard. Now, to make sure this all runs beautifully when you're dealing with tons of data, there are a couple of critical rules you absolutely have to follow. Getting this right is everything for Loki's performance. Listen up, because if you only remember one thing from this entire explainer, please make it this. You have to be so careful with label cardinality. Cardinality is just a fancy word for how many unique values a label has. Low cardinality labels, like job or environment, they're perfect. High cardinality labels, like a user ID or a request ID, they are a complete disaster. You will create millions of tiny log streams, you will overload Loki's index, and you will kill its performance. Filter for those values. Never, ever make them labels. So, to wrap up for production use, manage your label cardinality like your job depends on it. Use structured logging like JSON whenever you can. It'll make your life so much easier. Always, always start your queries with your most specific label selectors. And finally, be smart about your retention policies so you don't keep logs forever and run up a huge bill. And there you have it. You are now equipped to build a production-ready, incredibly cost-effective, centralized logging system with Grafana Loki. You can go from an alert to the root cause in a single click. But, logs are just one piece of the observability puzzle. So next time, we're going to explore distributed tracing to see how we can follow a single request across our entire system. See you then.